All right, today we're going to be adding a I/O point. First, I'm going to start with the software. I'm going to be adding this as a fuel gas flow transmitter. So I'm going to come to my inputs. I'm going to start here. First, I'm going to add a task. I'm going to use the new tag name as the name of the task. Then I'm going to open the task. I'm going to give it some rails and put it into manual layout. I'm going to come to variables in my new task, and I'm going to create the variable I'll be using to connect to the I/O card. In this case, we're going to call it a flow transmitter. Going to give it a description. Going to make it a real point. We're going to make it a global scope, so it can be used anywhere in the program. And then we're going to select a format spec. In this case, standard cubic feet a minute, 0 to 1500 with a decimal place of 2. We're going to tie that to the I/O card in the hardware. In this case, we're going to the hardware tab, and it's going to be on a PHRA card on location 2B4B. Input 1. So we're going to come here to the connected variable and input 1 on the inputs tab. We're going to put our tag name there. If we did it properly, the description should auto-populate. We're going to say it's used as a 4 to 20, with the 4 being 0 and the 20 milliamps being 1500. Then we're going to come back to our software tab, and we're going to create an AI block. As we drag it over, we have the device name, but this time we won't be the FT because it's not the transmitter. We're going to have an AI block that brings in the transmitter from the hardware tab into the software with some alarm and status conditioning. So that's why we use the AI block. We're going to call it an FI. We're going to add a description. And we're going to add a format spec. Now on the format spec, you don't get a drop down. So what I like to do is I make a little notepad that shows all the different format specs and information I'm be using, so I can cut and paste it. So I don't have to try to memorize the different format specs. I'm going to hit OK, and that'll drop it into position. Now I'm going to double click on this AI, and I'm going to go to my cheat sheet again. The input is going to be the FT, not the FI. And then I'm going to put some ranges in. I want the high scale to be 1500, the low 0. Engineering max will be 1500 with a 0. My low cutoff means it will be 0. I don't want it going below 0. I'm not going to do a time constant on this because I'll be using it for a totalizer a little later, and I don't want to mess up my totalizer. And my AI type is going to be direct. What that means is for 0 coming in, I get 0 out. 1500 in, I get 1500 out. If I needed to, say, square root this or make it where 0 to 100 was 0 to 1500, I would make that indirect scaling or indirect scale square root. But for this, we're just doing a nice, easy direct. Now, this will function if I download it, but I'm going to go ahead and drag it to the rail. The rails allow me to see information. They have no real function other than allow there to be a point of reference from where it's coming from. It'll also say underneath, if you set it up, it'll tell you where it's used. It'll also allow the line to change color once you download it and give you the status. If you don't have the rails, it doesn't do that. All right, so now we've added that AI. I'm gonna go ahead and add an alarm block because I want to know when this goes bad quality. I'm gonna come over here, I'm gonna drag an alarm block in. I'm going to connect it. And then once it's connected, I'm going to double click on it. I'm going to come here into the window, and on the detail pane on the left, I'll come over to alarms, and I want to put analog alarm default. And from here, I can scroll down and select which alarms I want it to have, highs, lows. For right now, I just want a bad quality. And as I do that, you see the bad quality shows up. I'll expand this so we can see it. And then I'm going to change this to a level 3 bad quality alarm. And that's done. And then I don't need to do this, but once again, I'm going to drag the BQ to the rail. And it'll tell me where it's used. Once again, it'll function without that. Now, here's another thing about alarm blocks. It appeared that you configure it here in the alarm block, but really you're configuring this point in the variable. Even if I erase this block, it will not erase the alarms. Because I can configure the alarms by either coming here, like I showed you, going to this point, the 01FI FGS164, and defining the alarms here. I can also go to where that point is configured, which is in this AI block, in variables. And when I come to that same point over here, if you look in the detail pane over here, you can see I have the same ability to add alarms. Let me show you. I can remove this bad quality. And when I come here and look at it, the bad quality no longer exists. It went away. The line doesn't erase, but you'll see there's no longer a BQ pin here. So let me further emphasize this. I'm going to come back into the AA block, and I'm going to tell it I do want the bad quality. And of course, the bad quality is still there. If I erase this, and I come back to the point, the BQ alarm is still there. And if I come here to the parent point, the 01FI FGS164, it still has analog alarm default enabled. It still has BQ alarms. And you'll see if I add the analog alarm block back and connect it to it, the BQ will show up. So in that way, the analog alarm block is just a way for you to interface and to give you a graphical representation and the logic of what alarms are configured for a point. However, erasing the analog alarm block does not erase the alarm. That has been a basic analog input, and the reason I use this AI block is so that I can get from a hardware point to a software point with the status word. So I'm going to go ahead and build this. And with a successful build with no warnings and no errors, check our status window so we can see everything that's going on the controllers. We're going to download. We want to check to make sure it's doing the application code because we just added this task. We want to check to make sure auto reconfiguration, if it's enabled, is going to download because we've added an IO point to a card. And then we're going to come down and we're going to find the card to make sure it's downloading. There it is. We want to make sure it's downloading to the card that we've actually made changes to. Then we're going to select next. We want to only download the backup file. We do not want to restart the controller and download. We're going to say next, just warning us, so you got to know what you're doing. And it's asking if we're sure you want to do this. So we're going to say yes. It's going to warn us that we have two cards that are not communicating with the designated controller. And that's because these are PSCAs. PSCA cards have an IO pack on them, like all IO cards, and they have two ports, IONET 1 and IONET 2. Now, most cards, IONET 1 goes to the R, IONET 2 goes to the S or to the T, have whatever configuration you have. But if you have more than one controller, you're going to get this warning saying that, hey, one of the controllers can't talk to the IO pack. And the reason being that the PSCA card, while it has two IONET ports, the second IONET port is for Modbus over Ethernet. So it's not connected to controller. So anytime you have a PSCA card in your system, you're going to get this warning. So we're just going to say, yeah, we understand why. Okay. It's going to tell us the other status from the other controllers, reporting the same thing. We're going to say, yes, okay. And then it's going to summarize the last two things we've approved. And we're going to like, yes, okay, we want to do this anyway. These IO modules are not actually missing. They're only seen from one controller. And it's going to tell us you got to be absolutely sure that you want to download with one of these IO packs not talking both ways. So we're going to say, okay, so that's 4 warnings from one type of card we're okay with. And now we're going to download. We're going to start with the designated controller. We're going to come to status, and under best practice, we're going to watch our firmware revision, make sure it doesn't brick and go to build 100 and turn red. And we're going to watch our system idle and frame idle time. So when we hit the start, it's going to download to the R. We'll see it's complete. You'll see for a moment the system idle time went down to almost 0 and it was orange. If it stayed orange, we'd sit here and wait until it came back up greater than 15 or 20%. Now that we see it's greater than 15 or 20%, we're going to hit accept and do the other controller. Now the reason I do this is so that there won't be short on idle time to sync the two together and we don't have a possibility of the controller crashing. We also looked and saw that we didn't have a build 100 for our firmware. If we go to download, if we have a build 100 for our firmware, that means the firmware is bricked, and when the controller downloads, it's going to crash. So what we do there is we'd actually terminate or we'd cancel our download. So now we're going to hit close and it should start the IO download. So it downloaded the processor, now it's doing the IO packs. And we see as the IO packs are downloaded, the IO configuration and quality is now equal. We go to our log, it says we have 4 warnings, so we're going to shut off the messages. And we know what these warnings are. Those 2 packs that can't hear, the PSCAs, and our application code running in the RNS processor has an app state, which is a block that I've got another video on that prevents you from rebooting the controller inadvertently. So now when we come, we can see the live values on the AI. We can see they haven't connected the device yet. We've got this line that's pink. If we hadn't dropped this line, we wouldn't have this pink line, which is why we use the rails. The pink line lets us know it's bad quality. And you'll also see that we have a status word of 16, which the AI block interfaces with the hardware card, and 16 is a bad quality, which that would flag our bad quality alarm, which we can see is true. And that is how you configure an analog input AI.